Kestrel 1-1, Mojave Tower, wind 0304, runway 30, clear for takeoff, right close traffic approved, and Kestrel 1-2, runway 30, line up and wait.
Mojave Tower just cleared both aircraft for what we call an airborne pickup. This is where the Chase T-38 will launch, circle back, and make a brake release call for XB-1. The pilot will engage full afterburner on all three engines as soon as the brake release call is made.
Brake, now.
And accelerate to 120 knots, where the throttles are then actually brought back to minimum afterburner. Doing it this way will make rotation easier, which happens at 150 knots, and the aircraft will leave the ground around 175 knots.
Airflow's on, transponders altitude, coming right.
Tristan Brandenburg, call sign Geppetto, is flying here. He just turned on the transponder and environmental control.
Clean and dry.
Copy, clean and dry, out of burner.
Control, I have card 1 complete. Next up, card 2, pacer check followed by gear retraction.
That voice you just heard is Aaron Young, who just qualified as test conductor on the program. And flying Chase in the T-38 is Matteo Brambilla, call sign Wiper.
65,000 on the clock.
Chase is talking here with Joshua Approach. They're the air traffic control agency, and they're coordinating permission to enter into the airspace over Edwards Air Force Base.
Kestrel 1-1.
And Kestrel 1-1, is flight level 290 going to be okay for you for the stage 2, or do you need something else?
And that is affirmative. We'll be working mainly below 20,000, 15,000 most likely. Yes, sir.
3, 2, 1. Mark 223, 5,110.
223, 5,210.
This is a pacer check. It would be a problem if XB-1 was seeing erroneous airspeed or altitude information. So we periodically compare the values between the two airplanes.
Control 1
United 2601, how's the ride?
Copy.
Clearance just came from control tower to retract the landing gear.
Go gear retraction. Chase, call when set.
Chase, 27.5.
Util lights are out. Standby gear. 3.
20.
Standby. Alright, 3, 2, 1. Mark.
This was the fastest we had ever retracted the landing gear. On Flight 2, we did so at 205 knots, and Flight 3 was 215 knots. This time we did 225 knots, which is the design speed limit for gear retraction.
Alright, ready for a climb?
Ready.
Test control, your go for the climb.
Coming up.
And test control reminders, altimeter 29902.
902 set.
Copy, we'll go for a flutter comm check if you're ready for that.
Ready.
Test flutter.
Loud and clear, flutter.
Usually just the test conductor will talk to the pilot, but sometimes there are test points so time compressed that an individual control station is authorized to immediately call for a termination of a test point. Flutter test points are like that because if there's a problem, it can get worse very quickly.
Test control, we have profile confirmed. We'll wait till you are on condition for go.
Copy.
Kestrel 1-1, you are cleared, restricted 2515, at or below flight level 180.
At or below 180, Kestrel 1-1 cleared into 2515.
Coming right. Alright, on condition, here comes Fez Profile 1.
Oh.
Yep, definitely feeling it vibrate the airplane.
Control.
This is compressed for the video. The floater sweeps actually take between 1 and 2 minutes each to complete.
Control, your go profile 2.
Recommend 5 degrees alignment.
Copy, Profile 2 is selected, and arm button's blue. Here comes Profile 2. Test is 3.9.
Chase is 2.5.
When they say 3.9, 2.5, they're referring to their fuel state. 3.9 means 3,900 pounds of fuel remaining.
Profile's complete.
Control, your go profile 3.
Copy, here comes Profile 3. Running.
3 of 8 total test profiles. This first test series really is a functional test of the flutter excitation system and our ability to interpret the results live in the control room.
Profile's complete, coming right.
We are reaching the edge of our authorized airspace and need to turn around and point back to Mojave.
Test control, profile 7 is confirmed. When on condition, you are go profile 7.
Test. Rolling out, flow 240. Alright, I'm on condition. Here comes profile 7. Running.
In the turn, we had a glitch with our telemetry system. This is critical for these flutter test points, so we need to stop and repeat the test point.
Test control, we had some data dropouts. If you can reset the sweep, we'll start over.
Copy, profile 7 selected, arm buttons blue, ready to go.
Go for profile 7.
Profile 7's running.
A lot of lather, rinse, repeat going on here. The difference in these profiles are in the duration, the force that the exciters produce, and the mode of the profile, be they symmetric or anti-symmetric, which means both wingtips are up and down at the same time, or one is up and one is down.
Test is 3-2.
Chase is 2-1.
Profile's complete.
Test your go profile 6.
Here comes profile 6. Running.
Test control, there's 1 minute left in the sweep. You've already seen 245 in this flight, so as soon as this profile ends, your go for the XL to 245, and you can do a fast look and we'll continue.
Test copies.
Test control, 15 seconds, and if you can give any feedback on anything you felt, any problems, ring, instruments, etc., while you're accelerating, we'd appreciate it.
You got it. Alright, profile's complete, accelerating to 245. Felt some vibes at 17 hertz and 38 hertz. It was less than I felt with the landing gear down, and I'm not feeling any hint of roll oscillation so far. A couple of the profiles got a little bit of a wing, like a kind of a jerky wing drop when I stopped the profile, but nothing concerning. Feels good. Alright, quick look complete.
Test control, your go for Excel to 260.
W260, and then chaser, clear pacer.
There's nothing scary here, so the clearance was just issued to accelerate to 260 knots indicated. From now on, each new speed test point is faster than XB1 has ever been up to that point.
Test control, I have card 4 complete. Next up, card 5, 260 HQ block.
Copy. Here comes HQ, FQ block. Here comes that pitch doublet in 3, 2, 1.
These doublets are an excitation of the axis. We're looking for behavior that's controllable, well damped, and generally in line with the predictions of how we thought the airplane would fly. The responses will change as the airplane goes faster, so we check it at each new speed.
I'm going to start to the left and then come back to the right.
Control.
And this will be a turn for area management.
Control.
Back to the right in 3, 2, 1. Mark.
These beautiful exterior shots are taken by Ruslan Fishenko, who is our backseat photographer inside the T-38.
Alright, couple little roll ratchets and a little bit of side slip buildup, but I'm happy to continue.
Test control, your go for HQ block.
Copy, we'll use this turn as the HQ block.
Control. Test control, I have card 5 complete. Next up, card 6, quick look. Once out of the turn, your go for Excel to 270.
Copy, 270. Test is 2-8.
Chase is 1-9.
Rolling out, flow 045. Accelerating to 270. Quick look complete.
Test control, your go for Excel to 280.
Copy 280, and chaser cleared pacer. 3, 2, 1. Mark 282, 15300.
290, 15320.
The T-38 has a known airspeed error of about 8 knots around this speed, so it isn't a big deal that the two airplanes read something different.
Copy 280 pitch doublet. There's been a 8 knot, Chase is showing us 8 knots faster than I'm showing on the last two pacer checks. You guys cool with that?
Test control, continue.
Copy. Alright, here comes flying qualities block. Pitch doublet in 3, 2, 1.
Here's a great view of a pitch doublet. You can see how XB1 has a disturbance that dampens out after a few oscillations.
Yeah, doublet in 3, 2, 1. Control is quiet.
Control, good yaw doublet, your go roll step.
Copy, we'll start to the left and come back to the right. Alright, back to the right in 3, 2, 1. Mark. Couple little ratchets, but smoother than 260. And rolling out.
Test control, good roll step, your go for HQ block.
I'm happy with the HQ. Let's continue.
Test control, I have card 7 complete. Next up is card 8 quick look, your go to Excel to 290.
Copy 290.
A quick look is simply a sampling of how the airplane feels to maneuver at the pilot's discretion.
Quick look complete, and Chase is indicating 0.6 indicated.
XB1 has an air data test boom with an electronic Mach calculator, and it is expected to be much more accurate than the T-38's operational air data probes and a very old-fashioned mechanical Mach meter.
Test control, your go to Excel to 0.6 as indicated on your MFD.
Copy, accelerating. Alright, there's 0.6 and 300 knots. Chase your cleared pacer. 3, 2, 1. Mark 300, 15.5.
310.63, 15.520.
Copy.
Test control, I have card 8 complete. Next up is card 9, 0.6 FQHQ block. Your go for pitch doublet.
Copy, I'm going to use a roll step for area management. Starting left and coming back to the right.
Geppetto elected to
Alright, pitch doublet in 3, 2, 1. Control's quiet.
Test control, good pitch doublet, your go yaw doublet.
Yaw doublet in 3, 2, 1. Mark.
great view of the
Control's quiet.
yaw doublet here. You can see how much roll actually occurs when we use the rudder pedals to control yaw.
Test control, your go for HQ block.
Copy. Alright, we'll continue on this heading until we get it to preserve airspace for the flutter block.
Control.
4-21, are you exiting the airspace VFR?
Caution.
Okay, we got a uncommanded motion fault.
Here's where the flutter excitation system starts to give us some trouble.
Do we need another cycle?
Yes, let's cycle the Fez.
For a reason unknown to us at this time, it simply refused to work on condition at 0.6 Mach. After landing, it was discovered that the gearbox in the left wingtip vane was beginning to fail, and we already worked with a vendor of the system who's applied a mechanical fix to the issue.
Test control, your go profile 3 and just watch altitude.
Thank you. Alright, here comes profile 3. Running.
Caution.
Alright, Fez fault. We got a motion fault.
Copy, let's restart again.
Copy.
Here we're trying turning it off and turning it back on again. There's not much else that we can do at this point.
Alright, fast power's off.
Test control, this can be our last attempt, and then we'll get the gear down and come back.
Sounds good.
Test control, your go profile 3.
Here comes profile 3.
Caution.
Alright, servo fault.
After trying for a third time, we have to stop. We had basically exhausted all of the fuel that we had budgeted for this test point, so we need to start heading back home.
Let's call it there on Fez. Do you have any desire to do the wind-up turn before coming in?
I'd love to.
I have card 10 complete. Let's go card 11, 2.5 G wind-up turn.
Copy, 2.5 G wind-up turn. On condition test is ready.
Geppetto is excited about this one. The wind-up turn is an opportunity to perform some more dynamic maneuvering in XP1. He is pulling for 2.5 times the force of gravity here. It's both a structural test point and it demonstrates some overhead for the 2G maneuvering turns that we'll need to use later in the program to remain inside of our airspace constraints while accelerating for supersonic.
Test control, I have wind-up turn complete. Card 11 complete. Next step is card 12 gear extension.
Copy, gear extension, slowing for 225.
Test control, you are go for gear extension.
Copy, utilizer out, chase call when set. Standby gear, 3, 2, 1, mark.
This is the last landing gear test point in the program. It's done at 225 knots, which is the design extend landing gear speed. Great extension.
Castor 1-1, we're turning back to...
Test control, we have 3 down locked. While waiting on timers, you are go airflow switch to RAM.
Copy, airflow switch RAM.
Here is another environmental control test point. We set up for an emergency source of airflow to the cockpit and intentionally depressurize the cabin to ensure that the valve that regulates cabin pressure does so in a controlled manner.
I could hear a little whistle, and then the airflow increased. Ears popped. It seemed like it wasn't an explosive depressurization. It felt like a fairly comfortable rate. Alright, I got 3 down lock dampers on, flight controls auto, anti-skids auto, expecting 169 on final.
Geppetto is running through the landing checklist here. Fuel state's low, but this is not an emergency. We had planned to be at this fuel state when setting up for the landing.
Yeah, we're ready to land.
Chase is negotiating for landing clearance, and the TC is reminding Geppetto to reconfigure the environmental control system before landing. The comms can get very busy, and it's an art form to manage 3 conversations at once.
Castor 1-2, the full stop and you're low cruise.
That is affirmative. 1-2, be full stop first pass, and I'll take right downwind for full stop right after.
Castor 1-1 flight, roger, runway 30, clear to land, wind 110 at 3, and you're low.
Affirm.
Castor flight.
Control your go step 8, keep airflow switch to on.
Copy, airflow switch on.
And any other feedback before LSO comms would be great.
Good airflow. No other feedback right now. And Chase, just confirm landing clearance.
Clear to land.
Copy, clear to land, thank you.
Test, have contact. Line up right.
Here our landing signal officer, Zach Plies, call sign Sprite, will start the process of verbally guiding Geppetto in for a landing. Sprite is a former naval aviator and used to do this on the back of aircraft carriers. It's a very refined skill.
Little high on center line. You're on glide slope, you're on center line. On glide slope, on center line. 50 feet, On center line, 40. On center line, 30. On center line, 20. 10. 5.
You have good brakes.
Brakes are close to 1,000 degrees Fahrenheit, but that's well within limits.
Test control, you're good for taxi back to FRI, brake temps look good.
Jess.
I hope this gave you a sense for what a mission is like. We appreciate the interest and keep following the channel as we approach the speed of sound over the next few missions.